So what is the consequence of particles that have these wave-like properties? All right, so we have these particles. They have what we would consider to be wave-like properties, and they have different consequences than normal pieces of matter that we would consider at our macroscopic, our large view. One of these things is the collapsing of the probabilities would mean something completely different if it happened at a macroscopic level. That means, really big. So macroscopic, when I say that, I just mean up at our level where we experience things, where we see baseballs and coffee and computers and whatnot, is where we experience life. And we don't experience it at the quantum level. But to give us a good idea of what would happen if these objects in our world, and don't get me wrong, quantum particles are in our world, but we don't experience them. We're not down there visibly perceiving what's going on at that level. But if the objects at our level were acting the same way as quantum particles, then what we would see is that when we measured them, they would also shift from one state to another. So for example, and this is a model known as Schrödinger's cat, and this doesn't actually happen. Like I said, this is a requirement that only happens for quantum particles, ones that have wave-like properties. But if we were to take this situation here and just as a model for what would happen if maybe this would exist at our level, we have a detector. And this detector, it detects the state of a quantum particle. And so the quantum particle, as we said, the electron, we'll say that this time it's an electron, because there's many different types of quantum particles, ones that have these wave-like properties and are very small. We'll say that one's in two different states, and this detector measures the state of the electron, and when it does, it says, okay, if it's in state 1, then I'm going to crush this vial of poison with a hammer, and the cat will die. But if I measure state 2, then the poison bottle will stay uncrushed, and the cat will stay alive. And so if we were to apply what we know about quantum particles now to this situation, what we would see is that not only would this quantum particle exist in both of those states, but now the detector would have both of those states, and the hammer would live in both of those states as well. The poison would be smashed and unsmashed, and the cat would be both alive and dead at the same time. So if we could extend this strange weirdness of the quantum states of electron to macroscopic objects like cats and hammers, we would see that the hammer and the cat were in both states at the same time until we opened this box and measured the state of the system. So that's the idea, is that this box is containing all of these things that are determined by a quantum particle, and so thereby creating a system where everything is in both states at the same time until we measure it and finally collapse it down into the one state. So once again, this is just a model. This is not something that can actually be accomplished, but it's how we could perceive the existence of a quantum particle as maybe a macroscopic object.